Don't stop when you are tired. Stop when you are done. Hello kids, I hope you all are staying fit and fine at home. Today children, we are going to start a new topic, that is the highest common factor. We have already heard a lot about HCF, which is the short form of highest common factors. So this is how we take out the HCF of two numbers. For example, we need to take out the HCF of two numbers given, that is 36 and 54. So to take out the common factors, first we need to take out the factors. Children, as we have already discussed in the previous video about the properties of factors, that 1 and the number itself is the factor of itself, right? So first we are going to write 1. 1 into 36 is the factor of 36. Then coming up to 2, then 2 18s are 36. When we come to 3, 3 12s are 36. Then 4 9s are 36 and 6 6s are 36. Children, you can think and ponder that if there is any other number too, you can mention it here. Then after that we are going to list the factors of 54. 1 into 54 is the first factor, then 2 into 27, then 3 into 18, and then 6 into 9. So here we are going to list the factors in the increasing order. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. And the factors of 54 are 1, 2, 3, 6, 9, 18, 27 and 54. So now for 1 is also a common factor, 2 is also a common factor, then 3 is again a common factor, 6 is a common factor, 9 is a common factor, 18 is also a common factor. So the highest common factor here is 18. So 18 is the greatest common factor or the highest common factor, and hence the HCF of 36 and 54 is 18. Now let's see the factorization method to find out HCF. The earlier method was by finding out the factors, and here in this method we are going to find out by the prime factors. So here first we are going to do the prime factorization. Children, the prime factorization is already discussed in the last video, and I hope you all have understood it very well. So we are first going to factorize the first number, that is 850. So when we factorize, children, so we check with the very first prime number first. How we see? By the divisibility criteria, which is again I have already discussed in my previous video. Since this number ends with 0, and we already know that when a number ends with 0, 2, 4, 6 and 8, then it is completely divisible by 2. After dividing 850 by 2, where we get the quotient 425, it ends with 5, so it won't be divisible by 2. For checking it for the divisibility of 3, we are going to add the digits. 4 plus 2 is 6, 6 plus 5 is 11. 11 is again not divisible by 3. So the next prime number is 5. And yes, we know that when a number ends with or in the units place it is 5 or 0, it is divisible by 5. So when we divided 425 with 5, we got the quotient 85. Now again, since it ends with 5, it won't be divisible by 2. 8 plus 5 is 13. So again 13 is not divisible by 3. So we are left with 5. Next number is 5, and since it has 5 in its unit place, it is divisible by 5. 5 17s are 85. So 850 as a prime factorization, we get 2 into 5 into 5 into 17. Similarly, we are going to factorize 680. And here we get 2 into 2 into 2 into 5 into 17. And now when we take out the HCF, we see 2 as a common factor, right? Then here 5 is also as a common factor, and then 17 also as a common factor. So how many common factors, prime factors we have? 2 into 5 into 17. So after multiplying all this, we get the HCF, that is 170. So the HCF of 850 and 680 is 170. Again, we are going to take another example to take out the HCF of 12 and 18. Factorizing 12, 12 comes in the table of 2, so 2 6 are 12. Then factorizing 6, 2 3s are 6, and 3 is again prime number, 3 1s are 3. Similarly, we are going to factorize 18 and we get 2 into 3 into 3. So how many common factors do we get here? We are going to get the common factors as the first one is 2 here, 2 and 2, then 3 and 3. How many common prime factors we have? 2 into 3. So the HCF of 12 and 18 is 6. Children, we have already discussed two methods. One was by listing the factors, then by doing the prime factorization, and now we are going to discuss the long division method. In this long division method, children, if two numbers are given to take out the HCF of, for example, 180 and 75. Here we have taken the example of 75 and 180. So the bigger number will become the dividend and the smaller number will become the divisor, and we'll divide it. We'll get a remainder. Now in the next step, the remainder will become the divisor and the divisor will become the dividend. 75 was divisor earlier, now it is going to become the dividend, and the remainder which we are going to get after division in the step 1, in step 2, that will become the divisor. Again we will be dividing, and in step 3 whatever we are getting, the remainder will become the divisor and the divisor will be becoming the dividend. Again we will divide until we get 0 at last. So HCF of 75 and 180 is 15. So the last divisor where we get the remainder 0 is the HCF. So the HCF of 75 and 180 is 15. Let's go to another example. 504 and 318. Children, as I have already told that the bigger number will become the dividend and the smaller number will become the divisor, and the division will continue till we get 0. How? By making the remainder as the divisor and making the divisor as the dividend, and keep on dividing until we get the remainder as 0. So here, after doing this long division, we have got HCF as 6. The HCF of 504 and 318 is 6. So children, in this video we have discussed 3 methods to find HCF. The very first one was to find out the factors, listing the factors. The second was the prime factorization, and the third is the long division method. In case of any queries, you can surely put your queries in the chat box, children. Take care of yourselves, children, and have a good day. Thank you.